Hello viewers, welcome to iTech Combo. In this tutorial we are going to learn k-nearest neighbor theorem. So let's see what does it tell. Let's say this is a type of data and this red is another type of data. So if we place a point, let's say this point out there blue, if we place this point, so what should be the classification of this point? Is this of this type or this black type? So the probability of this point of being this red colored type is greater one. So how can we say that? We say that since the distance of this blue point is smaller for this red point out there and then the black ones. If we draw, let's see, these are the distance out there. These are the distance out there, and these are the distance out there. Obviously, these distances out there is greater than this distance out there. So the probability of this point of being this type is greater. So according to k-nearest neighbor theorem, this point, the blue point out there, is of red type. So let's see this blue point out there. Obviously this point is near to this group of data and it's further from this group of data. According to k-nearest neighbor theorem, we can say that this data out there is of this black type. So let's code the k-nearest neighbor theorem. Import the numpy as np, import matplotlib dot pyplot as plt from matplotlib import style, import warnings from math, import square root. Okay, then from collections, import counter. I will be explaining this later. Let's style of the graph 538 GST. Okay, then let's make a data set. I will be making a data set. So I am giving a data set of type k and making the array of them. So let's take 10, 20 a point, then 20, 30 another point, then 30 and 10 another point of type k. Next I am taking another type, let's say R type of data, make the array out there 60, 50, 70, what should be the point? Okay, 70, 45 and another data let's take is 80 and 90 should be fine. Okay, so these are the points out there, and I want to make a code so that it can define this point out there 50, 70 out there. Find the classification of this data out there. Is it of K type or is it of R type by K-nearest theorem? So let's plot this data, how the data is look like. For this reason I am going to make, okay, let's see, if I make a for loop, first of all, if I load for I in dataset, then what will be loaded in I? It will be loaded for first time, it will be loaded K, then R. So here I is K for one time and R in another time. Then I want to do another thing. I want to do another thing. What should I do? In I, this array is out there, so I will make another loop out there. So let's make for I in what should I say, data set, okay, then I will be given out as input I, okay. Now I has this array out there. Now what should I do now? Now I will be use plot dot scatter, then I what should I give? I 0. So in I first time this array will be out there, okay, and in I 0 the X element will be there. So I am in plot dot scatter, I am giving the X element there. Now I have to give the Y element. So I 1. So I have given the Y element. Now I can give them a size of 100, then color of I, okay. Since I is K or R, so I will have for this data I will have black color, and for this data I will have red color, okay. Now what should I do? Okay, I have to make the bracket close out there, okay. Yeah, I think it's fine, okay. Now I have to plot this point too, okay. So plot this point, plot dot scatter, give the X value out there. So new feature 0, X value out there, and new feature, give the Y value out there 70, okay. Now you can give a size of let's give is 150. Yeah, 150 is fine. And you can give a marker out there, let's give a marker of, what should I say, plus, okay, plus should be fine. Okay, then okay, I am not giving the color out there, okay. Now I am giving the color, let's give it blue right now. I will be changing it right there afterwards. So let's see the plot. Run the code. Okay, there is an error, let's check. Okay, there is the error, it's not 70, it's 1. Now run the code, and you can see these are the points of one type, and these are the points of another type. Through K-nearest neighbor theorem, I will be finding if this plus symbol is of this data or this data. So let's go to the code. I will be defining a function of finding K-nearest theorem, okay. K nearest, okay. Let's keep data as input and predict find feature as another input and give m equal to by default it's 3. Okay, I will be explaining m later. Now so write if okay, length of data greater than equal m, then a warning will be sent out there. So warn m is set to a value less than the group of data type. So let's explain m here. Let's see the figure here. This is of one type data and this is of another type data. So there is two type of data. So if we see if we give length of data out there, then we will have, for this data set we will have a value of 2. Now if we set m equal m, and then what is m? M is let's say there are thousands of the data out there and there are thousands of data out there. We actually do not check all of them. For all of them we actually check for the nearest some points of data from here, and for the nearest some points of data, let's say for this data set we will check for this point and this point, and for this data set we will check the distance for this point and this point. So m will be here equal to 4. So if we set let's say there is another type of data out there. So if we set m greater than the length of data, that is data type, then there will be a error. So for this reason I am setting this error prompt. Now find the distances, make a empty array for group in data. Okay, for features in data group, so data, this is the data, whole array is the data, and in the group there will be k, either k or r. So from here data k, that is this array, features will be loaded out there. Now I will be finding distances, Euclidean distances. Now let's check what is Euclidean distance. So let's say this is a point out there and this is a point out there. I need to find the distance out there, Euclidean distance. So I have to follow this point, this formula, x minus x1 minus x2 whole square plus y1 minus y2 whole square. Then I have to make the root of the whole thing. So write Euclidean distance equal to square root, then I have to find a feature 0 minus feature not feature I have to find the distance of this point from these features. So x1 of feature, x1 of feature and x1 of predicted data. So let's here predicted data is the feature data. So write feature find feature of 0. Okay, now I have to make it square, so make it square, and now plus again feature 1 y value minus find feature 1, find feature 1, then I have to make it square, so make it square, and here is the distances. So I have to do a thing out there. This is the empty array out there. I will be appending this empty array. Oh, sorry. So distances dot append, and I will be giving the distance, Euclidean distance, and also its classification. So what is its classification? Group. So I will be giving the group. Okay, now now I have to count the board. For this reason, write boards equal I of 1 for I in shorted distance, and I will take points up to m. So if I set m equal to 3, then it will short the distance array, and it will take the first 3 element only. Then it will load these elements out there in I, and if we see, this array will be like this, k and 3 k, no sorry, this array will be like this. Here will be the distance, let's say 50, and here will be the group. So I will be loading the group in this board array. So let's go furtherward. Then I have to count the board result equal be counter. So I in this function will count the values of k out there, and most common. So most commons are will be k and r. So common, and this will the arrays will be of this type: k 3 times, r 3 times. Okay, so I will be only printing this this first point only. So for this reason 0 0. Okay, now I will be returning board result. Okay, now it's time to call the function here. So let's call the function prediction equal, this is the line, Ctrl C, this is the function. So let's okay, let's make it data to data set, and find feature to new feature. Okay, this was the name which we want to find the prediction. So now the prediction will be either k or r. Here I am changing the color to prediction. Now I want to also print out prediction. Okay, let's run the code now, and you can see this is the black point out there, and these are the red point out there, and it is classified as what say as black. And let's change the value of m. Let's change the value of m equal to, let's say, 5. Okay, now run the code. Again black. Okay, let's say how many points are there? 6. Okay, it's classified as black. So this is the prediction of k nearest neighbor. 10, 30. Okay, so this is all for this tutorial, I think. Okay, yeah, this is all for k nearest neighbor theorem. You can try with more than 2-dimensional array. You can try with multi-dimensional array for k nearest algorithm. So see you in another thing. Thank you all.